The Brain Electrophysiology Laboratory, or BEL, was originally founded on the University of Oregon campus and eventually became EGI. When we sold EGI in 2017, Fan Lu and I created the BEL Company to explore the next generation technologies in EEG and TES. We are pleased to introduce our next generation EEG source imaging and TES planning software, Sourcerer. With tools such as this, EEG can become an advanced neuroimaging technology at reasonable cost.
For the last 3 years, we have been working on a faster, easier, web-based EEG source analysis software called Sourcerer. Our team of scientists here at the BEL have been actively using Sourcerer in our own ongoing research. Sourcerer gives every EEG researcher the ability to easily obtain source estimates and visualize the results using state-of-the-art graphics. Imagine seeing the EEG at its source in the brain from a computer running a web browser. So to wrap up, some of the unique strengths of Sourcerer are its ease of use, ability to run on any computer platform, visualization capabilities that are intuitive, allowing the user to explore the results, and its workflow management to minimize wait time.
Hi, I'm Dr. Kyle Morgan, scientist at BEL, and I'm happy to be showing you Sourcerer today. One of the fundamental questions here at BEL is, how do we visualize the electrical activity of the brain? The latest research shows that EEG electrical source imaging is as accurate as MEG in finding the source of activity within the brain. However, performing source analysis has proved time-consuming for researchers. Sourcerer solves this issue by using cloud computing, advanced head tissue conductivity measurements, and user-friendly inverse methods to quickly solve for source activity. We can quickly go through some of the main features of Sourcerer. Sourcerer uses cloud computing, can be run on any computer operating the Chrome web browser, and it's not operating system dependent. Powerful data management and data exchange are included in the web-based interface. Users can choose from included standard Atlas head models with no MRI data required, building their own individual head model if MRI data is available, or having BEL build them an individual head model with their EEG and MRI data. A choice of inverse methods are provided for solving for source analysis. Each individual electrical dipole is registered on the brain and shows the anatomical activation on the scalp. The most advanced solutions for head tissue conductivity are included. Sourcerer 3D visualization includes flat map with Brodmann views, segmentation view, source localization views, interior brain with individual electrical dipoles, phase amplitude coupling visualization, plot of current density, and pure EEG view. So for our demo today, I'll load the EEG file as well as the MRI data to create an individual head model. Our method includes data of 7 different tissue types and calculates current flow through each of the tissue types. We can solve for source analysis of a particular time or event using one of these inverse methods: multiple sparse prior, Loretta, standardized Loretta, and frequency localization. What is great about using the Bayesian multiple sparse prior method is that you don't have to set thresholds, there are no regularization parameters to set, and it gives a more focal solution. Each individual electrical dipole is mapped and can be utilized in different ways. We can plot the lead field of a dipole and show the forward projection of scalp activity. We can see current density. We can see the interior brain with individual dipoles. We can also see an individual dipole plotted on the Brodmann map view. This truly shows how electricity works in 3D. We can also look at frequency localization that would be appropriate for epilepsy, or many other applications where we want to see the brain's oscillations. Sourcerer includes other visualization tools: the flat map with Brodmann areas outlined, segmentation views, source localization views, phase amplitude coupling view of an imported file, and pure EEG view. In a future update of the software, Sourcerer will include TES, or transcranial electrical stimulation planning. With cloud services technology through AWS, we're able to deliver a platform-independent interface through local visualization code contained securely within the Chrome web browser. Through standard RESTful web interfaces, users can access their secure laboratory database from any internet connection location and draw on the computational resources of the secure cloud. Computations are completed by the cloud ahead of time so that when the researcher is ready to explore the data, the workflow is fast and efficient.
The advances in electrical neuroscience are providing new technologies for understanding the human brain and for manipulating brain activity through the application of electrical fields. The new product set that BEL is now announcing will provide a range of both software and hardware to advance these technologies in research laboratories worldwide.